everyone, welcome back to my math teaching online. In this video, I will talk about the radical function as well. However, we will dealing with a different question. But before I get into the lesson, please allow me to advertise a little bit for my online courses. Over the past 3 months, I have published the first course, Introduction to Calculus Course 1, and the second, Introduction to Calculus Course 2, which is the two important fundamental in calculus for everyone who want to learn about calculus and want to understand what calculus means. Regardless any major you might take in the university, usually you have to take at least one calculus level for any major. So my course will help you to have a basic foundation understanding for the concept of calculus. And if you take it in the university, it will be very tough because the timing and time management extremely important. It's the first factor decide your success. So if you have to take 4 or 5 courses, the material is not too hard, but because the time consumed is so fast, it might become difficult. Taking my course in advance or after, either way doesn't affect your learning. It should help you for your learning. It's more beneficial. So compare the cons and cons. And because when I developed the course online, I had to buy the platform to purchase the platform to create my online course. So therefore, I cannot give it to you for free, but I have to at least take back a little bit so that I can keep on going and serve our global education. I hope you understand that. And again, my cost, if you purchase as a bundle, it will be reduced by $80 USD dollar. So it's very cheap. Anyway, that is my advertisement for my online courses. You can purchase it through mathcourses-online.teachable.com. So before I get into the lesson, I take a little bit time talking about my course. I hope that you will check it out and recommend it to anybody if you like my teaching online. So let's get into the question right now. I'm going to read this question out loud to you, right? So let me, sorry about this mess. I'm going to read it. Write the radical function in the form of y equals a square root of b times x minus c plus d. If you follow me on the previous lesson, you will all know about this is the vertical stretch of factor a, horizontal stretch or shrink cone by a factor b, followed by the shift left or right by letter c, followed by shifted up or down by letter d. So we have two functions on the board here. And we're going to base on this sketching function and figure out what is the right equation for these two functions. So let's do the number 1 here first. However, before I get into this, I would like to explain a little bit outside so that you understand what we are doing here. So let's say if you have a function y equal 2 square root of x. This is a radical function we're talking about. Now, the reason we call a radical function because we have a unknown letter as a member inside the radical. And that's why it's a radical function. So now let me write this in a different way. If I don't want to write a 2 in front of square root x, can I write this function as square root 4x? So the answer is obviously yes. And when you bring the 2 inside the radical, all what you have to do is compensate by power back to 2, because you take it out by the square root of 2. When you bring it back inside, you have to power back to the power 2. So 2 to the power 2 become 4. So obviously, these two equations exactly one equation with the same formula. Now, if I express this as the letter A, which is I have a vertical stretch by a factor of 2, but if I put in here, I will say this is the horizontal shrink cone, right? Shrink cone by 1/4, because we do 1/b. So whether we express it as a vertical stretch or a horizontal shrink cone, we have the same equation. It means we have the same radical function with the same shape. So let me give you another example. Let's say if I have y equal 1/2 square root x. Now, if I bring it inside, I can write it as the y equal 1/4 in front of the x. And this expressed as the letter B, and this expressed as the letter A. Now, in terms of radical, when you sketch it, let's say your basic shape like this. And now, your height from here to here will be shrink cone and become down this way. So whether you express as a vertical shrink cone by 1/2, or this point will move down to here, and it means this one is no longer become, this x no longer stay like this, but it will be expanded, right? Horizontally. So in terms of vertical shrink cone, it becomes horizontal expansion. But the shape of the function doesn't change. It's exactly the same shape. So that is a special feature of the special characteristic of our radical function. So I'm going to, based on this equation, I'm going to tell you how we're going to write out the equation for our function here, using the idea of whether we can design our equation at a vertical stretch of A or horizontal stretch of B. We don't have to do both. We just need to pick one, either of them. Our equation is the same. So based on that idea I just explained to you out here, we're going to do this here. So let me get into the first equation. So the first equation have an endpoint here, which is -1 for x and -2 for y. Now, because our original basic like this, we have a point of 0 and 0. But the endpoint here will indicate whether we move our function left or right, up or down. So obviously from 0 and 0 here, it become -1. So it means this point moved to the left by 1 unit and push it down by 2 units. So therefore, anytime you have a radical function, the letters C and D here indicate the endpoint. So we know this is talking about the endpoint, C and D. So therefore, to write out the equation of this function, we will establish the equation y equal A, and we can choose A first Ignore the b because it's going to be the same. And inside we have x minus c plus d. So we're going to write this equation. We're going to fill up the letter. We're going to substitute the letter y or x or a or c or d here by all the number we know. And we will left with one unknown number a. In that way, we can solve the equation. So I'm going to substitute the c and the d first because this is the end point and I know it. So I'm going to rewrite this as x minus c. Our c is minus 1. However, remember we shift to the left. So minus with minus will become plus 1. And the d here will become shift down by unit 2, so minus 2. So first we substitute c and d because we know the end point. What next we have to pay attention? Because they give us the shape like this, so we can base on the shape and we inspect. Do we have a reflection on the x-axis or do we have a reflection on the y-axis? So let's say we're not worried about the y-axis because we don't have a b in here. However, okay, let me see. Let's look at this shape here. The basic shape this way. Now the transformation this way. So it looked like we have the vertical reflection, right, over the y-axis. We have the reflection over the y-axis. So this will become this shape. And now when it becomes this, we realize that this also have a horizontal, no, sorry. We also have a reflection over the axis because the shape looks like this. So we know that our A here will have a reflection over the axis. So, but also, we also realize that we have a reflection over the y-axis. However, we don't have to worry about the B, so let's forget about the B. Let's talk about the A now because we established based on the A. So we know that based on the A, we have a reflection over the x-axis. But let me see. We're not talking about the B, but because we have to write the equation in the shape of whatever it is. So yes, we know that we do have a negative in front of the bracket here as a reflection of the y-axis over this way, like this, and then reflection over the x-axis. However, because we solve for a letter A, so let's assume this is a positive, but when we write this equation, make sure we know the shape, right? Because they provide us the shape and provide us the point. So we're going to substitute the point by the end point, but also we realize this is the reflection over the y-axis. So let's put a negative here. Now for the A, should we put the reflection here? I think so as well, because that's how we establish our equation, right? So make sure on the right, the notation are correct. So we have reflection over the x-axis because we are given the shape, so we know. So we'll say reflection over the x, reflection over the y, and we have the shift down -2, and we have a C is minus. So minus, the formula is minus. So minus with minus become plus. So now, after we fill out the C and D, we're gonna substitute the A here. And we don't worry about the B, right? Because we just need to solve for A and we don't need to solve for B. So here, our Y will become, because we substitute this point already. So now we have to use another point to substitute for Y and X in here. So our Y is minus 4 and minus A just minus A. And let's see, minus. And our X is minus 5. So we substitute X by minus 5 plus 1 and minus 2. So what do we end up? We end up with minus times minus plus. But let's do it inside first, right? So inside is minus 4, become minus 5, add 1 is minus 4. But this minus we change this become positive. So now we're going to solve for this, continue for this. I'm going to move here, right, to solve for it. So we're going to move the 2 here to the left side. And when I move in equation, I have to switch the sign, negative 2 become positive 2. So I have minus 4 plus 2 equal minus A. Inside, I have a 4. So that will give me minus 2 equal minus, take out the square root of 4 is 2A. Divide both sides by 2. Let's divide by minus 2. Then we have positive 1 equal A. So now we know A equal 1. So substitute into the equation, we'll write this first equation as Y equal 1 for A, but remember, because we're talking about the shape here, we have reflection. So this side is still there and A equal 1. That minus 1 square root of X square root of minus X minus X and plus 1. And outside minus 2. So this is the final equation after we write for the first function. So now I'm going to show you how to write for the second function. So I'm going to copy the equation here for this one will be Y equal minus square root of minus X plus 1 minus 2. Now we're going to do the second equation here. For the second equation, we've paid attention to the endpoint, right? And again, I'm going to write, so this is second, the sketching here, I haven't touched this part, right? So the sketching here, we will have A. Now, this time I can choose whether I want to do horizontal stretch or vertical stretch. And before I have done to solve for A for this question already. So now for this question, I use B for now. So you can see we can use A or B, right? So I'm going to use B for this. So I'm going to say B and X minus C plus D. First, I establish the transformation. Now I'm going to pay attention to the shape of this function, right? Based on the shape, we know that this is the original shape. It just stretched vertically, but it doesn't change, right? It's still in this way. And actually, we do have a reflection over the axis, right? We do have reflection over the axis based on the shape. However, we don't have a reflection over the y-axis. So we just reflect this function here, and then we move here, right? So based on the shape, we have the reflection over the x-axis. So I'm going to put the negative here. Okay. And I'm going to write out this is B. So now I'm going to substitute. I'm going to leave the B here, but I'm just going to substitute the C by the end point. So our C equal 3 for x. So we know we move to the right. So this have to be negative 3. And our y is shift up by 1. So this become plus 1. Now I'm going to substitute another point down here into this equation and solve for B. So our y here is minus 7 equal our x is 7. So B is just B and our x is 7. And our 3 is just the same. That's what. So we have minus 7 when I move this. It become negative 1, add to here become negative a equal negative 4b. 7 minus 3 is 4b. So now I am going to take out the 4 first. So I have minus a equal minus 2, right? I just take out the root and the b is still inside the square root. So now I'm going to isolate the square root b and I'm going to divide both sides by minus 2. So that will gone and that minus a divided by minus 2 will be equal positive 4. Positive 4 equals square root of b. So now I'm going to solve for b. I have to power back, right? Power b. And I have to power both sides for the scale still balance. So I will have 16 equal b. So now we know our value b. We can plug back into this equation right now. So this is our first equation. And our second equation will be y equal minus still minus because we base on the shape of this, right? Minus. Inside we have a 16 for b. And we have an x minus the c is 3 and plus 1. So this is our second equation. And you see that we can solve this equation easily by looking at the shape and we plug in the point in here. So let me summarize a little bit what we're doing here. We understand the concept that whether we stretch vertically or shrink horizontally, if we do reverse, the shape of the radical function stays the same. So we will decide it, do we want to write equation in terms of factor A or in terms of factor B. So we don't have to do both, but we can do either of them. So in the first information, the first sketch, I use the letter A. So we substitute any value we know based on the information, make observation of our shape, whether it reflects over the y-axis or reflect over the x-axis. We make sure we make the side correctly based on the shape they provide us. Then we substitute on the value we know in the function using the end point and 1 point on the graph. Then we substitute in, we solve for whether letter A or letter B. And then after we solve for A or B, we plug it back into equation and we ended up with the first equation here. Actually, this is the second equation and this is the first equation to answer this. So I hope that you enjoy my teaching and you understand about what I'm trying to explain about the lesson. So I will show you, we haven't done yet, I will show you how to write the equation based on, see what I mean when whether we either we can stretch the vertical or we can shrink on the horizontal. The shape of our radical is not changing. Okay, so let's do that. So first, let me establish. Let's do A first, right? So I'm going to say this is as a vertical stretch. Let's do that. Now stretch or compress, right? So let's do that. It will be y equal a square root x minus c plus d. So this is the formula, right? The formula always have a negative here. But our c could be positive or negative, right? So where's the starting point? The starting point here is the end point, right? I call an end point. Some people will call starting point. Doesn't matter. You know that, right? So this is x, it's y. And we know we move the x to the right 5 units because this is positive. And we shift down by negative. So I'm going to replace the c by x minus 5, right? We move to the right, so this is negative side. And d is shift down, so negative 1. Now I'm going to use this point. This is another point on the graph, right? So I'm going to substitute this point into this equation and solve for a. So the y here, this is y, this is x. Y here 2, I substitute by 2, a, just a. X will be 21 minus 5 minus 1. So I have 2 equals square root of 16 minus 1. Move the 1 over, I have 3, add into this, right? Negative become positive, add to that become 3. Take the root of 16, I have 3 equals 4a. Divide both sides by 4. Cancel that, I have a equals 3 over 4. Minus 1. Now, because we don't have a shape for this, so we can decide it, whether it have reflection or not, I guess. So we just say a here equal 3 over 4. We substitute radical. Our x is just x minus 5 and minus 1. So this is our equation. Now, because we don't know the shape, so let's leave it for now, like as this, okay? Now, let's do the same equation, the same coordinate point, but this time we will decide as a factor of b. Okay, so I'm going to have to borrow some, a piece of board from here, right? So now let's do this. So again, the y is 2, still 2. The a here disappear, but we do have the b, right? Let me substitute step by step. So bx minus 5 minus 1. So let's solve for this. So I'm going to substitute the y here by number 2 here, right? So we have 2 equal y equal, we say this is b. Our x is 21, I'm substitute x by 21, minus 5, minus 1. So now I'm going to move this over, so that's still equal 3. When I move, this negative become positive, add to here become 3. I am going to calculate it out, which is 16b. So now I'm going to take out the root of 16. So I will have 3 equal 4 square root of b. Divide both sides by 4. I have 3 over 4 equals square root of b. So now to solve for b, because this is square root, so I have the power 2, right? So that the power here can cancel out with the root. And because I power 2 on the right, I have the power 2 on the left as well to keep the balance side the same, right? So turn out my b will be equal 9 over 16 equal my b when I power it. So our equation for as a factor b will become y equal, right here, our b is 9/16, right? 9/16. X is argument 5, minus 1. Now, obviously, you can see that it's true. If we move this inside, we're going to have the power of the 3, which is equal 9, and we're going to have the power of the 4 equal 16. And that's our equation as a factor b. Now, because we don't have a shape of this one, so we're not going to know whether it's reflect whatever. But let's see, let's try it and see how we're going to figure it out. So mark a little bit. Our first is 5 and minus 1. So let's say this is 2, this is 4, this is 5, and minus 1 is here. So 5 and minus 1. So that's our end point. Our other point on the way from here, 1 and 2, and on the way out here. So you can see if you connect this, it looks like something like that, right? So you can see that we don't have any reflection over the y or over the x. It's the shape like the basic shape like that. It just we move up or down, right? So that's the idea. When we sketching the second question based on the data given, no draft, and we can decide whether we want to express it as the factor of A or the factor of B. Now these two equations exactly the same and exactly the same shape of the radical, right? So I'm ending my video in here, and I hope that you will enjoy my video. I think it's the light a little bit dark now because the sunshine is put another way, but I'm standing in this room, so it's no change in terms of the darkness. I could not control that. I hope that you still can see it very well on the board, right? So thank you for watching, and I hope that you enjoy my teaching, and I hope that if you know anyone to want to learn about the calculus and you like my teaching, you can recommend it. Go to my mathcourses-online.teachable.com. And as I said to you that I just get the prize in terms of getting back from me some money to buy the platform to make this lesson plan for all of us, right? So I hope you will support me on my math teaching online. Have a good day, everyone. Thanks for watching, and bye for now.